The Ferrari Testarossa was developed in a context where Ferrari needed a rear engine model capable of stable operation with greater power than the previous generation. The wide body was not an aesthetic choice, but a technical requirement to address cooling and heat distribution for the 12-cylinder flat engine. At the beginning of the project, Ferrari engineers were confronted with increasing thermal loads that could no longer be managed through traditional rear-engine layouts. Rising power output demanded a fundamentally different approach to airflow management rather than incremental refinement. Body panels were shaped to direct airflow straight to the rear engine bay while reducing pressure buildup at high speeds. The wide body structure allowed expansion of intake surfaces without increasing overall height, keeping the center of gravity low. The chassis used a tubular steel structure combined with torsional reinforcement points, suited to rear-engine layout and high torque. Body rigidity was prioritized to ensure precise response during high-speed road operation. Joints between chassis and body were tightly aligned to control geometric tolerances, factors directly affecting stability and mechanical noise. Panel gaps were kept within technical limits to ensure consistency over long-term operation. Side body sections were designed with extended vents, allowing stable airflow under various operating conditions. This structure cooled the engine bay without needing larger traditional intakes. These side structures were engineered not as add-on ducts, but as integral load-bearing body elements. Cooling efficiency and structural integrity were developed simultaneously rather than sequentially. The front hood and trunk were designed low to improve forward visibility and reduce drag. Large surfaces were kept flat to maintain aerodynamic stability at high speeds. The windshield was angled appropriately to balance downforce and comfort during long-distance driving. The single-piece roof increased overall body rigidity compared to removable top configurations. The rear was widened to cover the entire engine and drivetrain bay while maintaining bilateral symmetry along the longitudinal axis. This design gave the Testarossa the stability needed for a high-power road car. Exterior details served no purely decorative purpose. All were for technical or identification reasons. Every crease and flat surface was calculated to meet cooling, rigidity, and production requirements of early 1980s Ferrari. Upon completing the chassis and body, the Ferrari Testarossa was ready to receive mechanical systems. At this stage, the car already had the full structural foundation to handle high power, substantial weight, and the demanding stability requirements of a new generation Ferrari. The Ferrari Testarossa was equipped with a 12-cylinder opposed flat engine of 4.9 liters, arranged horizontally in flat 12 configuration. This layout lowered the center of gravity while reducing overall engine bay height in the rear engine placement. The engine block used aluminum to control weight, combined with dual overhead camshafts per bank to maintain stable high RPM operation. This design reflected Ferrari and Oppo's philosophy in the early 1980s, prioritizing large displacement and sustained power delivery. Unlike compact high-revving engines, the Testarossa's flat 12 emphasized torque continuity and thermal stability over sudden power spikes. This characteristic shaped both vehicle dynamics and driving style. The intake system used Weber carburetors, delivering fuel directly to each cylinder bank. Choosing carburetors over electronic fuel injection reflected common Ferrari technical standards of the period, while allowing direct mechanical tuning to engine characteristics. The exhaust system was symmetrically arranged, optimizing outflow and reducing back pressure at high RPM. The resulting sound was a direct consequence of engine structure and pipe geometry, not electronic processing. The engine was integrated with a 5-speed manual gearbox, forming a compact drivetrain unit positioned behind the cabin. This layout shifted weight distribution rearward, suited to Ferrari and Oppo's rear-engine sport car character. The multi-plate clutch was designed to handle high torque, ensuring stable power transfer under hard acceleration. A short drive shaft connected directly to the rear wheels, minimizing mechanical losses and maximizing response. Suspension used double wishbone configuration at both axles, allowing independent wheel motion control and stable road contact. This setup suited the wide body and high power of the Testarossa. Ventilated disc brakes were fitted to all four wheels, meeting deceleration demands of a heavy, high-speed car. The braking system was designed for consistent performance during extended operation. Mechanical steering without power assistance was retained to ensure direct front-wheel feedback. This approach reflected Ferrari and Oppo's era philosophy, prioritizing driving feel over comfort. At low speeds, steering effort was significant, reinforcing the Testarossa's character as a serious performance machine rather than a casual touring car. Driver input remained central to control at all times. The entire electrical and ignition system was laid out simply for easy access in maintenance and adjustment. Every component served stable operation rather than electronic optimization. Upon completion of assembly, the Testarossa possessed a drivetrain suited to its role as a high-performance road sports car. Large displacement engine, rational layout, and direct mechanical structure created the distinct operating character of this Ferrari period. At this point, the Ferrari Testarossa had completed its core technical foundation. Remaining elements were not to add power, but to ensure the driver could effectively and controllably exploit this mechanical system. The Ferrari Testarossa cabin space was designed around the driver and Oppo's position, reflecting the control priority of 1980 sports cars. Component layout focused on quick, precise operation rather than touring car comfort. Seats featured low, wide structure, supporting the body under hard acceleration and cornering. Low seating positioned the driver to clearly feel chassis and suspension movement, while keeping driver center of gravity aligned with rear engine layout. Long-distance comfort was achieved not through softness, but through posture stability. The seating allowed sustained driving without excessive fatigue, while preserving constant feedback from the vehicle. The instrument panel prioritized critical operating information. Engine RPM was in direct line of sight, reflecting the engine and Oppo's central role in Ferrari philosophy. Auxiliary gauges surrounded it to provide necessary data without distraction. The steering wheel was appropriately sized, directly connected to mechanical steering. Front wheel feedback transmitted straight to the driver and Oppo's hands without electronic intermediation, suiting Testarossa control character. The mechanical shift lever with short throws allowed precise, decisive gear changes. This layout enabled high-speed manual shifting without direct visual reference. Each shift demanded deliberate input, reinforcing the mechanical rhythm of driving rather than allowing passive operation. Cabin contact surfaces were finished to withstand heat and vibration from the rear engine bay. Interior design prioritized durability and long-term usability under real operating conditions. The Testarossa exterior was developed based on technical requirements more than decoration. Wide, low proportions improved high-speed stability and supported cooling for the large displacement engine. Side vents were integrated directly into body structure, ensuring stable airflow without additional separate elements. This technical solution became inseparable from Testarossa identification. Rear engine placement and symmetrical exhaust directly influenced tail shape. Every detail served heat control and rational weight distribution. Lighting, glass, and exterior details met 1980s road use standards, ensuring daily drivability within the framework of a high-performance sports car. At this stage, interior and exterior were no longer separate considerations. They formed a unified operating environment shaped entirely by mechanical necessity and driver control. After full assembly, the Ferrari Testarossa entered the final inspection phase before being allowed to leave the factory. The goal of this stage was not further performance optimization, but confirmation that all systems operated to design specifications. The body was checked for straightness and panel fit to ensure no deviations developed in operation. Minor errors potentially affecting stability and mechanical noise were eliminated here. The engine system was run under controlled procedure to verify stable temperature and pressure maintenance. Operating parameters were continuously monitored to confirm normal working condition. This phase emphasized consistency rather than peak performance. A Testarossa was approved only when it demonstrated predictable behavior across repeated operating cycles. The drivetrain was tested for load bearing and response under speed changes. Gearbox and clutch were evaluated for shift smoothness and continuous power transfer capability. The braking system was tested for deceleration effectiveness under various conditions. The aim was even force distribution and sustained stability during extended operation. Suspension was tested across motion ranges to confirm body control capability. Vibration and stability were assessed to ensure suitability for wide body and high power. Steering was aligned for precision and direct feedback. Any minor deviations were corrected to preserve original Testarossa handling character. The electrical and ignition system underwent full function checks, ensuring stable operation under road use conditions. Connection points were confirmed safe and serviceable. After completing technical checks, the car was certified to Ferrari operating standards. No additional testing phase followed this step. At inspection completion, the Ferrari Testarossa was no longer viewed as a work in progress. It became a ready-to-use vehicle, fully meeting the technical and legal requirements of its era. After inspection completion, the Ferrari Testarossa left production status and entered real-world use. From this point, the car no longer belonged to internal technical processes but became a vehicle operating on public roads. All mechanical systems were designed for stable operation in daily conditions, not just factory-controlled environments. Engine, drivetrain, and suspension began working as originally intended in development. The Testarossa was positioned as a high-performance road sports car. It was not optimized for track use, but for sustaining high speeds over long periods with high control. Extended highway travel revealed the Testarossa's true character. Stability, thermal balance, and mechanical consistency mattered more than short bursts of acceleration. During operation, the driver held the central role in all control processes. Without deep electronic intervention, all feedback came directly from mechanical systems. Handover marked the moment Ferrari transferred operating responsibility from manufacturer to owner. From here, how the car was used depended entirely on the driver. The Testarossa was not created as a display object. It was designed to move, to operate at high speeds, and to maintain technical character throughout its service life. In the 1980s context, the Testarossa represented Ferrari and Oppo's approach to road sports cars: large displacement engine, wide structure, and pure mechanics. These elements directly reflected the technical standards and user expectations of the period. Ownership required understanding. The Testarossa rewarded mechanical sympathy and disciplined driving rather than casual use. As the Testarossa left the handover point and continued its journey on public roads, the production process officially concluded. What remained was not procedure or specifications, but a complete car ready to be used exactly as originally intended.